In this next lesson, we're going to start exploring angle pairs. And those are just angles that can be named in special ways. So when we're talking about two different angles, we can call them different things. The first one we're going to talk about are adjacent angles. What makes them special is that one, they're coplanar and they have the same vertex and one common side. But their points on the inside do not overlap. So what does that mean? Well, I like to call this bird feet. So here is an angle, and then there's an adjacent angle. Notice how my pen makes like a bird foot. These are not adjacent angles. Notice how I had to pick up my pen. Not adjacent angles. So anything that shares a common vertex, so right here would be the vertex, and one common side. So we're going to start to talk about naming two adjacent angles. There are more than a couple adjacent angles in here. One of them we could call AOB, so angle AOB, and notice how BOC makes that bird foot I was talking about, and angle BOC, those are adjacent. Angle AOB is also adjacent with angle BOD. The common side that both of these sets of adjacent angles share is ray OB. Another set of adjacent angles would be angle BOC and angle COD. These two sets of adjacent angles share the common ray of OC. Now, if I talk about non-adjacent angles, that would be an example of angle AOB and angle COD. Both of those angles, while they share a common vertex, do not share a common side. Another example of non-adjacent angles would be angle AOC. So angle AOC is here. And then if I talk about angle BOD and angle AOC are non-adjacent because they share common interior points right here. The next thing we're going to talk about again, and you've seen this definition before, is opposite rays. And those are rays that go in opposite directions to form a straight angle. So there are two sets of opposite rays here. Ray OC and ray OB. Those are opposite rays. Notice how they form that straight line of BC. And then another pair would be OA and OD. Those form the line AB or AD. The next word we're going to talk about is vertical angles. And those are two angles whose sides are opposite rays. Notice that if I label these 1 and 2, 1 and 2 are vertical angles. They make a perfect X. That's what I like to call it, perfect X. 3 and 4 are also vertical angles. I can also name angle 3 AOC and I can name angle 4 BOD. There's just different ways to name angles as we have seen. Complementary angles are two angles whose sum is 90 degrees. So for example, if I tell you that these are complementary angles, that would mean if this one is 30, then this one is 60. Or if this one was 20, then this one is 70. So they always add up to 90 degrees. Okay, supplementary angles. This has the wrong definition here. We'll get rid of that. It's a typo on my part. They are angles that add up to 180 degrees. Angles that add to 180 degrees. So for example, these two right here, angle AOB and angle AOC, make a straight line and they add up to 180 degrees. So if this one's 30, then this one's 150. Also, you have AOC and COD forming a straight line. So those are also supplementary angles. And then you have other pairs of supplementary angles, just anywhere where they form a straight line. The next word we have is an angle bisector. An angle bisector is a ray that divides the angle into two adjacent and congruent angles. These angles definitely do not look congruent to me, but I'm telling you they're congruent. I'm telling you that AOB and BOC are congruent. You denote that with arcs inside of them, meaning if this one is 30, then this one is 30. Angle bisector cuts the angle into two equal parts. Here's a couple of examples then. I'm telling you that this is 42. AOB is 42 degrees. So if this is 42 degrees, it's telling me to figure out what BOC is. Well, BOC must be 42 also because those two angles are equal. In this next example, I have still the directions that OB bisects angle AOC, but I'm given that AOB is 37 this time, and I'm supposed to find AOC. Well, I know BOC is 37, so that means the entire angle has to be 37 plus 37, which is 74. Again, we have an angle bisector. Even if they don't look to be bisecting each other, because the instructions say that they are a bisector, we have to believe that to be true. So that means that AOB and BOC are congruent. So if I'm given x values for those, so this is 3x plus 11, and this one is 6x minus 10, I can set this equation up so that they are equal to each other because I know that angle bisector makes two equal angles. And so what I'll do is go ahead and solve this. I'll move the 3x over. More than one way to solve this problem. I will add 10. No matter how you solve it, you will still get the x of 7. Now, they're not asking me for the x value, they're asking me for AOB. So I have to plug the 7 in for my x value. So that would give me 3 times 7. So I'll write that here. 3 times 7 plus 11. Because AOB was 3x plus 11, and I put 7 in for that. So I get 21 plus 11, which is 32. In the next example here, I have angle AOB is 5x plus 14, but this time they tell me BOC is 7x minus 10. Again, I know these two angles are equal, so I'm going to go about it the same way. I set them equal to each other, and I'll solve this equation. No matter which way you choose to solve it, you will get your x value to be 12. This time it asked me to find AOC. I don't have AOC to plug it into, but I have both of these which make AOC. So I can put 5x plus 14, which is AOB, and plug in my 12. That gives me 60 plus 14, which is 74. I know then that this angle is 74 degrees, so that means that this one is 74 degrees because they were equal. And now when I add those together, I will get 148 degrees. In this next example, I have angle AOB is 3x plus 5, and I have AOC, which is the whole thing, is 7x. This one's different. Those two angles are definitely not equal to each other. So what I need to do is I need to come up with another name for this one. Well, I can call it 3x plus 5 because these two are equal. So that allows me to write an equation. Two of those smaller angles equals my larger angle. So when I distribute, I get 6x plus 10 equals 7x. No matter what way you solve it, you will end up with x is 10. And then you can plug that back in to AOC. AOC is 7x, and so when I plug 10 in, I end up with the answer of 70. Last example, very similar to the last one, except I have BOC, which is 2x minus 7, and I have AOC, which is 3x. That means that this one also is 2x minus 7. So I need 2 of my smaller angles that will equal my larger angle. And when I distribute, no matter which way I solve it, I will get that x is 14. I'm supposed to find AOB. I don't have AOB to plug it in back for, but I know that AOB is the same as BOC. So I'm going to plug it into 2x minus 7. And so I'll have 2 times 14 minus 7. That's 28 minus 7, which is 21.